steak. As soon as it enters my mouth, digestion begins. I chew to break it down into manageable chunks. My tongue mixes saliva into the beefy mix, and off it goes through my digestive system. You should already know about the digestive system. If not, you may want to watch this video first. We've previously discovered that different enzymes break down different food molecules, which is quite important, because we saw that digesting lipids was a little more complicated and required bile and emulsification to help along the way, which is what we're going to look at in more detail in this video. Before we start, let's think about why we chew to break up our food, and why our stomach muscles churn up the semi-digested mix. It increases the surface area for the enzymes to work on, thus speeding up the rate at which our body can break down the food to extract the energy from it that we require. Now let's fast forward to our stomach. Our chewed up, stomach churned food has a large surface area and is mixed with the stomach's gastric juices. These are watery, and these, together with the watery saliva secretions of the oral cavity, mean that the food is now in quite a watery solution. This is called chyme. If you've ever added water to a greasy pan after cooking, you'll know that water and fats and oils, or lipids, don't mix too well. You end up with oily droplets. Pretty much the same thing happens in our stomach. Our watery mixture of chyme contains big globules of fats and oils, which won't be mixed into the solution. This is a problem because it means that the lipids have a small surface area for the lipid-digesting lipase enzymes to work on. The lipase enzymes are added in the small intestine. At the same time, a special substance called bile is also added to the chyme. The bile increases the surface area of the big fat globules by breaking them up into smaller fat droplets. The increased surface area of the lipid droplets increases the rate of digestion of lipids by the lipase enzymes, because more lipid is available for digestion at any given time. Lipase enzymes can now more quickly break the lipids up into fatty acids and glycerol thanks to the bile addition. The process of increasing the surface area of the lipids is called emulsification. The bile is produced in the liver and stored in the gallbladder. It's released down the bile duct into the small intestine from the gallbladder. Not only does the bile increase the surface area of the lipids, it also has another great quality. It's alkaline. This helps to neutralize the strong hydrochloric acid which is added to the chyme, and provides a more optimum pH for enzymes in the small intestine to work in. To end with a random fact, the bile is green in colour, and it's this that makes your poop brown. In this video, we've learned that bile is produced in the liver and stored in the gallbladder. From here, it's released down the bile duct into the small intestine, where it divides big globules of lipids into smaller droplets. This increases the surface area of lipids available for the lipid-digesting lipase